Alrighty, welcome to section 1.4, which is dealing with functions. We want to start with the most important definition in this section, and really in chapter 1 is dealing with what does it mean to be a function. And I'm going to ask you this every day you walk in, what does it mean to be a function? According to your book, a function f from set A to set B is a relation that assigns to each element in X in the set of A to exactly, and that's the big key word, to exactly one element Y in the set of B. Okay, which is a lot of mumbo jumbo for most of us. Here's the Algebra 2 version that we use. What it said is for every X, there is exactly one, I'm going to highlight this as much as I can, one Y. And that was the big definition, and we did that on and on and on again in Algebra 2. And so that's, I don't care which definition you know, as long as you can tell me that in order for it to be a function, for every X, you have to have only one Y. Now the question is, what are the X's? What are they talking about? Your book defines this original set A to be the domain. And the domain we learned in Algebra 2 is the set of inputs, or what we called our X values. Okay, and the set B, which is that second set, are the output values, which are the range values. And the range just means the Y's. Okay, and so domain and range, we're coming back to that as well. Your book describes 4 ways to represent a function. We're going to give you just a general linear function, y equals 3x. Algebraically, it just really means use the equation. Okay, so the equation here is y equals 3x. Verbally means how would you say this to me if I said, what does this equation mean? And you would say y equals 3 times x, or 3x. And I'm kind of okay with either. It's that idea that you can put it in words. Numerically is the idea of a table where we picked some x values and we plugged them in our function to get the y's. So like -1, 0, 1, we'll just do a couple. If x is -1, -1 times 3 gets -3. And again, I'm using this function. If x is 0, 0 times 3 is 0. And if x is 1, 1 times 3 is 3. And so that's the third way to represent, is if we ask you numerically to write a table. And the fourth way is with a graph. And so I'm going to plot these points, -1, -3, 0, 0, and 1, 3. And you'll notice if I extend this in both directions, I end up getting a line. What's special about this line is we talked about in section 1.3, this 3 is the slope, and it's not represented here, but if I put a +0, this 0 would be my y-intercept. And so that kind of ties us back into what we did in section 1.3. And so the biggest thing, again, this definition by far is the most important definition, and you have to be able to tell us what it means to be a function. So let me slide down to the second part. And the second part, we're talking about function notation. And we're going to be using this idea. We're going to use this idea for what I'm going to call DQ. And I'm going to shorthand that. That's coming up. It's called the difference quotient. And so we got to make sure that we understand this in order to be able to do the last idea from this chapter, or from this section, I'm sorry. I'm going to take you a little bit differently, and I'm going to ask you things like, what does f of something mean? Well, f is really the same thing as just the y value. We just represent it in a function notation. This says basically that this is a graph, which is a function of x, and for every input you get one output. And so what I'm going to do is show you how it works, and just let's go silly for a little bit. If I ask you f of smiley face, that means take 2 times the smiley face squared plus 3 times the smiley face. And what ends up happening then is for every x I see, I plug in whatever is there, okay? And so let's say I did f of anything, you can call it whatever you want. This p, plug in for x, okay? And so you're going to plug that in for every x that you see. Now in the second one, let me set, instead of saying f of x, let me change this to a y. F of y would mean 2y squared plus 3 times y, because instead of doing the x that was originally there, I'm going to plug the y in. Now the last two are slightly different. F of 2 I can actually evaluate, and evaluate means find the value of the expression. And so I'm going to slide this over a second. F of 2 means plug the 2 in. 3 times 2 squared. Oh, let me try again. 2 times 2 squared, plus 3 times 2. Well, 2 times 2 squared is just 8. 3 times 2 is 6. If I add them together, I get 14. And so you're plugging it in. Once you plug it in, you evaluate the right side of that expression. The fourth one is the one that's most important kind of as we go through. This again will help us with our difference quotient. And so I want to look at this, and for every place we see an x, I'm going to throw in this x plus 2. Okay, so 2 times x plus 2 squared plus 3 times x plus 2. And you have to simplify this as much as you possibly can, because eventually I'm going to get some like terms. And so what I'm going to do, I'm going to change colors a second. Let me pick a different color. This part right here means FOIL. It means that there are 2 of them there and we want you to FOIL it out. So let me see if I can simplify this for you. X squared plus 4x plus 4. Again, please remember this really means that there are 2 of them. Okay, don't forget this 3. I'm going to distribute this 3 in. Plus 3x plus 6. And now all I'm going to do is a little simplifying. Take a second, pause the video if you would, and then from there, if you can actually simplify this, you end up getting 2x squared plus 11x plus 10. Okay, and you're looking then into the most simplified form. If you're not sure how this ends up being there, again, please make sure that you ask in class tomorrow. And so that's the main idea. Again, this is something that we're going to be doing for difference quotients coming up. One thing that you never discussed in Algebra 2 is this idea of a piecewise function. And all it means is that based on the interval, it will tell you how your graph works. And so what I need to do is look at these definitions here where they're saying, this says if x is 0 or a negative number. This says if x is positive, then I'm going to use this function. So depending on whatever number they ask you to find will depend on which function you use. So this says find g of -4. Because it's negative, I'm going to go to that first equation, and I'm going to plug the -4 into the 2x plus 5. And if I plug this in, 2 times -4 is -8, plus 5 ends up getting -3. And so the value of this piecewise function at -4 would end up being -3. So I try the second one. At 0 means that I'm going to put, let me try this again, at 0, I'm going to put it in the top one again. So 2 times 0 plus 5 ends up being 5. Okay, the last one is positive number, so I'm going to put it into the bottom equation. So I take 7 and square it, plus 3. 49 plus 3 ends up being 52. And this is the idea of a piecewise function. It's the idea that if I modify the intervals, it tells you then which function to use. And so it all depends on what type of value they're asking you to do. At this point, please go ahead and turn your page over. Let's go to the back side. We talked a bit already about domain and range. Domain is the set, that's supposed to be an S, the set of all x values. I want you also to put on their inputs because your book is going to use that word input. Range is the set of all outputs or all y values. Okay, and those again are definitions that you should also know. They help you then define a function. And so we're going to look at a couple of questions about domain and range. Okay, what I want you to do, you can talk about domain and range a couple of ways. You can take this on your calculator and just look at the graph of your calculator and say, okay, what x's do I have? What y's do I have? I'm going to at least show you the domain by hand. We can talk about range in class, but range I would definitely look at your calculator. Basically, if you're going to square root, you cannot have the square root of a negative number or you have imaginary numbers. And so what I want is I want that x minus 9 to be either positive or 0. As long as it's not negative, we're okay. Well, I'm going to solve this to figure out what x should be by adding 9 to both sides. X has to be then greater than or equal to 9. And this is my domain. These are the values that x has to be in order for this to actually be a function. If you look at your graph can help you find the range. And if we look at our graph, according to this, and I'm just going to shorthand this a little bit, but let's say this is 9. Your graph will end up looking something like this. And at 9, if I plug a 9 in, 9, let me do this. If I plug a 9 in, the square root of 9 minus 9 is the square root of 0, which is just 0. And so at 9, I get this point 0, and then I get a square root function from there. It goes something like this. Now taking a look at that graph, can you tell me the range? What y values do you have? And in this case, you'll notice they never go down here in the negative portion. So what we say is either non-negative reals, which means it can't be negative. And this is just the symbol for real numbers. Or we say it, you could do positive reals with a plus sign. Or you could say it reals greater than or equal to 0. And I'm trying to show you some shorthand. I'll talk more about that in class. But I wanted you to get that idea of the fact that you can say real numbers by using this R. Okay, and again, there's nothing down here. And that's why we start at 0 and go positive from there. Okay. So let's talk about domain and range. Domain is the x values, range is the y. So taking a set, I'm going to shorthand this a little bit with domain and range. They give us a set. If this is domain is x's, I want to talk about my x's. My x's I'm going to leave in purple and I'll change my color for the range. Those are all of the possible x values. The biggest thing is please put them in order. Okay? So my lowest number is -1, and then 2, and then 3, and then 5. You will notice I did not duplicate because I know I have 2 values that are 3s, but I don't want to duplicate those values. Okay? Let me also change my color a second. And let's talk about range, which are those y values. 4, 5, 6, 1, and 0. And again, I'm going to put those in order. 0, 1, 4, 5, and 6. And I'm going to put those brackets outside as well. And so as you're looking at them, if they start in these little braces or these brackets, they also have to be included in domain and range. In part B, I want to talk about part B, and then I'm going to actually leave those other 2. I would like you to try these 2 and have them ready for class. Okay, and that's what we're gonna start tomorrow morning with, is if you can have those ready. I'm just gonna look at B. And so as I look at here, you have a fraction. You can never have 0 in the denominator of a fraction or it's undefined. And so my only restriction here is that I can't have 0 in this denominator. And so what I'm going to do is I'm going to set this equal to 0 to figure out when that would happen. And so I'm going to subtract 5 on both sides. This is saying that if x is negative 5, I get an undefined fraction. Therefore, my domain is all reals except, and we just say not equal to, negative 5. Okay, so all reals except wherever it would give me an undefined answer. And then for my range, what I'm going to do is I'm going to plug this into my calculator. And then I'm going to look at my table or my graph. Is there any number I can't touch? And what ends up happening is no matter what, I'm never going to get a fraction equal to 0 because this numerator could never equal 0. And the only way to get 0 is if you take 0 divided by something. That can't happen if there's a 1 on top. And so here's my domain and range for this function. In my opinion, domain and range are two of the harder topics as we go through. Just kind of figuring out, looking at a graph though on a calculator is sometimes an easier method at looking at it. So far we've covered function notation, piecewise functions, and domain and range. The last topic is an introduction to calculus. So we're going to move our way down there. And this one is called the difference quotient. We give you the formula, okay? And this one, again, you should kind of circle it, star it, whatever. We're going to be using this. We'll do some modifications of it along the way, but this is the idea. A difference quotient ends up finding a slope. And we're going to give you functions that, like the one below, that are not always going to be lines. And we don't normally find slopes unless they're lines. And this is the idea of calculus. You're going to be able to do some of these basic ideas without actually having basic functions. And so what I'm going to do is I'm going to start with this f of x plus h. What that means, and we did this at the front, is wherever I see that x, I'm going to plug in an x plus h and then minus 5. So this is that first idea of this f of x plus h. I then subtract f of x, which is this whole function, 3x. I'm going to put this in parentheses, 3x minus 5. So I subtract the whole function, and I divide it all by h. I'm going to do a little simplifying for a moment. Okay, I'm going to say, well, 3 times x, and I'm going to distribute this in, plus 3 times h, minus 5. And then I'm going to distribute this negative into both of them as well. Minus 3x plus 5. Now, take a look at what's left. You should notice that things cancel out. And whenever you do a difference quotient, there are going to be things like 3x and negative 3x that'll cancel, and 5 and negative 5 that will also cancel. You're left with 3h over h, and assuming that by definition h isn't 0, my answer then is 3. What we told you from the beginning is a difference quotient is a slope. Based on this line, isn't the slope of this line going to be 3? The answer should be yes, because again, I should be able to show that that slope is 3. Now this is going to get a little harder as we go through, so let me walk you through setup on the next one, and I'm going to ask you guys in class to finish. I'll get you the answer. I want you to try and finish it, and then we're going to do more difference quotient in class. So take a look. If I start with x plus h, I need to plug something in for here and here. So I have x plus h squared minus 4 times an x plus h plus 7. That is that whole idea of f of x plus h. That's what I did, is for every x, I threw in this x plus h. Now I'm going to subtract my entire original equation. X squared minus 4x plus 7, and I'm going to divide it all by h. Our goal is to simplify this, and truthfully, guys, the reason we get this question wrong the most is because of our algebra skills. This means FOIL. So x squared plus 2xh plus h squared. I'm going to take the negative 4 and distribute it, minus 4x minus 4h. I have a plus 7 here. And then I'm going to distribute the negative one more time. Minus x squared, positive 4x, positive 7, all divided by h. And you better find things that cancel out. If things don't cancel out, then we've done something wrong. The x squareds will cancel. The 4x's will cancel. Oh, and I already forgot to distribute this right. The negative 7 and the positive 7 also cancel. So if I look at what's left, 2xh plus h squared minus 4h, all divided by h. Another thing to keep in mind that you should always have h's in what's ever left. Cancel out an h from each on top and bottom. You're left with 2x plus h minus 4. We have to assume if I have h's left that h cannot be 0. Because if h were equal to 0, we never could have done this problem because dividing by 0 gets us an undefined fraction. What this answer allows us to do is to find the slope at any value of x. At any value of x. And difference quotient is one of the harder things in this chapter. Please understand that we will do this again in class, and we will be spending quite a lot of time on this. Thank you for watching the 1-4 lecture. Please make sure you're ready for tomorrow in class with whatever questions you had from this lesson, and we'll work on some homework questions in class as well.